example, you are saying that they are supposed to be weak acid is available. At the same time, just wait a minute. I had to meet with Sayyid Yusuf. No section, no class, nothing. That's daily problem. Daily kapde utar ke aata hai gadha. If it is so, then how to proceed? First of all, for that purpose, I'll do. Be careful. It's a very beautiful discussion. Be careful. I'm having acetic acid, weak acid, monobasic, acetic acid, CH3, COOH. It dissociates to give you CH3, COO minus, and H plus. C 0, 0. C into 1 minus alpha, C alpha, C alpha. Now, if suppose, for example, you are having this type of discussion, then we proceed with this one, that H plus ion concentration is C alpha. Alpha is degree of dissociation, right? This is the degree of dissociation. Remember, it is degree of dissociation in presence of water. Whenever we are discussing something like this, it is always in terms of presence of water only. There will be some value of alpha, that how to calculate alpha, we know very well, under root K into K by C. Today our discussion is not that. Our discussion is, suppose for example, if I am saying, sir, there is a container in which we are having strong acid HCl, and it is dissociating. If it is dissociating because you are saying it is a strong acid, therefore definitely this is supposed to be completely ionized. Therefore, we draw something like this. Irreversible reaction, and there is a formation of H plus ion and Cl minus ion. Since I am taking two acids, therefore I'll write like this, C1. Keep in mind, C1 is concentration of strong acid. This is 0, this is 0. At time t is equal to t, this is 0, this is C1, this is C1 because it is a strong electrolyte, it is completely ionized. It is completely ionized. Now I am taking acetic acid. If I take acetic acid, CH3COOH, listen carefully, try to understand the influence. We are having H plus ion concentration, we are having CH3COO minus. This is C1, no, C2. What is C2? Concentration of weak acid. This is C1 because it is already available in the container, right? And this is 0. Now, if you dissociate it, this is C2 as usual, 1 minus alpha. This is C1 already available, plus it becomes C2 alpha, and this is no chance was there. Now it is only C2 alpha. We are having only one that is coming from weak electrolyte, that is called C2 alpha. Okay, this is first point we have to learn. What is the next point? Next point is, sir, if it is so, what is this and what is this? Are they same? No. Remember, this is degree of dissociation. Alpha is degree of dissociation in water. Whereas now you are discussing degree of dissociation in presence of strong electrolyte. Go back, flashback. What happens in presence of strong electrolyte? Weak electrolyte undergo less dissociation. Degree of dissociation of weak electrolyte is further suppressed. We have studied one concept known as common ion effect. Yes, because of that common ion effect, why H plus ion concentration is more? Since H plus ion concentration is more, reaction goes to backward direction, right? Therefore, rate of forward reaction decreases. Hence, we should say that it is the discussion in case of presence of HCl. Earlier it was like this, right? Both rate of forward and backward are same. But now we are saying, no, sir, not like that. We are having degree of dissociation to be suppressed. And once degree of dissociation is suppressed, we say, this is not alpha value, sir. This is supposed to be new value of alpha. Therefore, we identify this to be as dash, alpha dash. And what is alpha dash? Alpha dash is degree of dissociation in presence of strong electrolyte. And what happens due to common effect, alpha dash is very much less than alpha. How much less than alpha? I have shown you example in the previous class. Alpha dash is very much less than alpha. Therefore, alpha dash becomes negligible. This is experimental fact of common effect, negligible, right? Hence, if you are having a weak electrolyte in presence of strong electrolyte, our question is, what is pH value, right? What is our mind says? Our mind says very simple. If you want to find out pH value, take H plus ion concentration. Then he will say you, where from here take H plus ion concentration? Very simple. You take H plus ion concentration from HCl and from acetic acid. No, it is wrong. Why it is wrong? Because of common ion effect. Now see what happens. Suppose, for example, if you want to take H plus ion concentration of acetic acid in presence of acetic acid in presence of HCl, what happens? Nothing will happen, sir. It is C1 plus C2 alpha dash. But what is alpha dash? Alpha dash is very much less. Therefore, remember, this becomes negligible, right? It is negligible, not countable due to what? Due to dash, common ion effect. Therefore, resultant H plus ion concentration is never controlled by weak electrolyte. It is always controlled by dash, strong electrolyte. Remember that point. This is the controlling situation of H plus ion concentration. Weak electrolyte is trying to supply some H plus ion, but the problem is those H plus ions are not counted because of common ion effect, right? So if you want to write down pH, what is pH? Sir, pH is simply minus log of C1. What is C1? C1 is concentration of H plus ion from dash acid. From which acid? Strong acid. Take down this much, then I'll proceed. Please come into the classroom in time. Now it's locking period finished. Okay. Neither you, some of you बहुत अच्छे हैं सिस्टमैटिकली, कुछ हैं जो अभी भी मेंटली डिस्टर्ब हैं, बगैर कपड़ों के क्लास में आ रहे हैं, ना उनका ड्रेस मालूम है ना क्लास मालूम है, और 2:45 के बाद आ रहे हैं जैसे कि उनके डैडी के घर का दीवान खाना है. It all nothing, it's reflecting your manners. चलो ठीक है, बोलना बेकार है. Go ahead. If it is over, write on the chat box. We'll proceed accordingly. Right. Very good. Suppose, for example, you are saying, sir, we are talking about H plus ion concentration. We have taken a case where you are having what you said just now. We are having a substance which is one strong electrolyte and one weak electrolyte. Come on, let us take another case. This is all numerical problems I am solving. You say, sir, no, I am having a mixture of, I am having a dibasic acid. Monobasic we have done, let us take dibasic acid. So our job is to find out the pH, H plus ion concentration of a dibasic weak acid. Nice. How to go? Very simple, sir. Let us take an example. Now here I'll do practical example. H2S, hydrogen sulfide. It is made to dissolve in water. It undergo ionization. Right? Remember that there is water here. What we are trying. I am lazy fellow, therefore I am writing like this. Okay. Conceptual discussion is this is first stage of dissociation. Suppose it is C 0 0 C into 1 minus alpha 1. What is alpha 1? First stage of degree of dissociation. This is C alpha 1. Capital. No problem. C alpha 1, C alpha 1. All right. Now for this, if suppose for example you want to write Ka, let us understand that also. This is called Ka1. What is Ka1? Ka1 is concentration of H plus ion into concentration of Hs minus by concentration of unionized, undissociated H2S. That is the method of writing, right? This is to be done in the form of C alpha 1 and all this, but I am not interested in that one. Okay, one thing is very important for IIT students. They'll ask you what is a H plus ion concentration. You can say at this stage C alpha 1, at this stage C alpha 1, but we are talking about second dissociation also. Okay, I'll let this to be as C alpha 1. Concentration of Hs minus is equal to C alpha 1. Concentration of unionized H2S molecule, it is called C into 1 minus alpha 1. That is quite obvious. Now, second dissociation takes place. What is second dissociation? See carefully. Hs minus dissociates to give you H plus and S2 minus. Now, what I have read here, at time t is equal to 0. This is C alpha 1, already available in the container. Already available in the container. This is C alpha 1. It is also available in the container. This fellow is newly born baby. Therefore, we read 0. If suppose, for example, you write time t is equal to t, as usual, we'll say, sir, this is C alpha 1 into 1 minus alpha 2. Second stage of dissociation. Second stage of dissociation. This is C alpha 1 was present. Now it is C alpha 1 alpha 2. I hope you are able to understand. C alpha 1 into alpha 2. Like that. This is called total concentration of H plus ion. And what about sulfide? This is newly born baby, C alpha 1 by alpha 2. This is the concentration available at the second stage of dissociation. And for that, we have tried Ka2. Okay, come here. Ka2. What is Ka2? Very simple, sir. Ka2 is concentration of H plus ion into concentration of sulfide ion into concentration of Hs minus. Right? Now, what is the discussion? K2, whatever with the number given to you, that will be given in the examination. H plus ion concentration. What is H plus ion concentration? In the second stage, C alpha 1 plus C alpha 1 alpha 2. Right? This is H plus ion concentration. into concentration of sulfide ion. Suppose I want to enjoy a new game. Sir, I want to calculate new H plus sulfide ion concentration. Okay. And then what is this? Left out. What is left out? C alpha 1 minus C alpha 1 alpha 2. Are you able to see this one properly? Here, if I am expanding it like this. Right? This is called K2. Now there is a problem. What is the problem? Sir, this fellow is C alpha 1 alpha 2. What is alpha 1 alpha 2? Remember that alpha 2 is second stage of degree of dissociation. Alpha 2 is degree of dissociation of HS minus ion. Now listen carefully. The beauty of subject is HS minus ion. H2S is weak acid. Very good. H2S is weak acid. And what we have learned, conjugate base. HS minus is conjugate base. Conjugate base of weak acid is a strong base. HS minus is a strong base. No, 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 no. I want to study acidic property of HS minus. If it is strong base, definitely it will be a weaker acid. Why you are calling it to be an acid? Because it has replaceable H plus ion. Therefore, we have said in Bronsted theory, this fellow is amphoteric in nature. Because it has a negative charge, it will be having tendency to attract proton, Bronsted base. Because it is having hydrogen, it can release H plus ion, Bronsted acid. But because it is a strong conjugate base, it is automatically a weak acid. Once you are saying it is weak acid, H2S is weak acid. No, no, sir. HS minus is weaker acid. Therefore, now we are saying alpha 2 is degree of dissociation of weak acid in presence of stronger acid. Hence, alpha 2 is very much less negligible as compared to alpha 1 of H2S because of common ion effect. Yes, this is the point which we have to enjoy. Common ion effect. In all dibasic and tribasic acid, second stage dissociation is supposed to be always less. Therefore, alpha is less. Suppose if it is, for example, if you are saying, sir, let me enjoy the game of phosphoric acid. If you are crazy enough to enjoy the games, alpha 3 is very much less than alpha 2, very much less than alpha 1. This is 4 marks question. This is 4 marks question. And luckily, today in our grand test, this question came here that if suppose you are having phosphoric acid, how do you go for enjoyment of this? And this came in NEET examination today morning. Come on. If it is so, what we have to say? Nothing, sir. We have to say that this is supposed to be neglected due to common ion effect. Out. Due to common ion effect. Out. And then what is left out now? Left out is, sir, Ka2 is equal to dash. See the very beautiful conclusion. I can calculate the concentration of sulfide ion directly in case of dibasic weak acid. Fine. Now, sir, what is our discussion? Our discussion is not this one. This is, by the way, we got some profit in business, but real business is what is H plus ion concentration? H plus ion concentration is C alpha 1 plus C alpha 1 alpha 2, and as usual, I have to say this is to be cancelled because of common ion. Got the point. This is the story in case of weak dibasic acid. Take down this, then enjoy another story. Correct. Fine, very good. Now, come to next case. J. 10th case. A very beautiful story here. Mixture H plus ion concentration of doctors. Enjoy the beauty. Scientists, it is must for you. H plus ion concentration of mixture of acids. You can do the same thing for mixture of bases also. If people are genius and you are very sincere daily, you are doing study at home, you can do it as home for bases. Come on. Suppose, for example, if it is so, now I am having HA. Who is this fellow? Weak acid. Dissociates to give you H plus and A minus. C1, 0, 0. C1 into 1 minus alpha 1. Alpha 1 is for first weak acid. Nice. No, you are saying, no. I want to take one more fellow, but I'm adding the same container. Both are weak. Both are weak. Remember, your mind should not go to common ion effect. In case of common ion effect, one should be weak electrolyte, one should be strong electrolyte. Remember, here in this case, we have both of these acids are patients, right? Here we have H plus ion concentration and we have A minus. Sorry, B minus. No problem. B minus. Nice. Come on. What is this? C2. Very good. C here C1 alpha 1 already present. And this is 0. Are you able to enjoy? Yes, sir. This is C2 into 1 minus alpha 2 degree of dissociation for the weak electrolyte number 2. I want some space here. Let me enjoy this A1. A1 is here. Something. What is that? C1 alpha 1. Now, if it is available, then here what happens? It is C2 alpha 2. No, sir. Earlier it was already available with us. Therefore, it is to be called as C1 alpha 1 plus C2 alpha 2. This is C1 alpha 1 plus C2 alpha 2. Sir, is it common ion effect? No, this is called simultaneous equilibrium. It's a new patient here, new case. What is that new case? Whenever we are having two weak acids as a mixture, then I have to count all the concentration of H plus ion from both the solutions because I cannot neglect it. If you are neglecting, common ion effect. One is weak fellow, one is strong fellow. If you are not neglecting, both are weak fellows, and the concept is called simultaneous solubility. Sorry, simultaneous equilibrium. This is also C2 alpha 2 because I cannot say Ha is having red colored H plus ions, Hb is having blue colored H plus ions. No, they are H plus ions. Therefore, overall concentration B minus. What is B minus? B minus is very simple, sir. C2 alpha 2. Therefore, overall H plus ion concentration is taken from both of this. But we don't count like this. See here, the beauty is it is not common enough. It is a simultaneous equilibrium. If it is so, then we'll proceed a new approach in our life, as you have done in your lower classes, conservation of mass. Remember, in the universe, as you were saying, law of conservation of mass is applicable exactly in a similar way in the universe. One more thing is applicable, known as law of conservation of charge. We cannot create a charge, we cannot destroy charge, we can transfer charge from one body to the other body. This is the concept. Therefore, according to conservation of charge. When I say like this, you people say, sir, you are talking physics tone. Yes. No, no. Let us talk about chemistry tone. According to charge balancing method. We call it as in physical chemistry, charge balancing method. What is that? Mass balancing method. Calcium oxide 56, carbon dioxide 44, calcium carbonate 100. Yes. What you are doing? Law of conservation of mass. Physics people say, no, no, no. If you are talking about balancing of the mass, here charge balancing. What is the meaning of charge balancing? Total cationic charge is equal to total negative charge. Okay. Now, how to proceed for this? Doctors, just have a look here, and then you have to memorize the final statement as you memorize the biological sciences. Memorize that one. Scientists enjoy the beauty of the flow of subject, how it is flowing. How to proceed for that? Suppose, for example, if you say, sir, I am talking about Ka. What is Ka? 1 is equal to concentration of H plus ion into concentration of A minus by concentration of Ha. Similarly, Ka2, what is that fellow? This is not second stage dissociation as I have done in case of what you said, H2S. It is second electrolyte, second weak electrolyte. It is equal to concentration of H plus into concentration of its anion by undissociated Hb. Okay. Now, total positive charge, whole H plus ion concentration is equal to concentration of negative charge plus concentration of negative charge. Right? This is called charge balancing equation, charge balancing method. IIT students enjoy this one, right? Come on. If you say so, here this implies, shall I say, concentration of A minus is equal to Ka1 into concentration of unionized Ha and concentration of H plus. Right? Similarly, if you want to have a cheating process, concentration of B minus is equal to K2 into concentration of Hb by concentration of H plus. Now, if you want to solve that, let us take enjoyment of space here, and then concentration of H plus ion is equal to, come on, concentration of A minus, where is that fellow? Ka1 into concentration of unionized molecules. What is that unionized molecule? Sir, this is HaC1 minus C1 alpha 1. C1 minus C1 alpha 1. Right, but C1 alpha 1 is supposed to be constant quantity. Therefore, we can say, sir, it is a negligible value. Actually, what I should write here in place of Ha, see here Ha, C1 into 1 minus alpha 1. It is C1 minus C1 alpha 1. Right? Alpha is very much negligible. Therefore, we say it is C1. What is C1? Concentration of weak acid Ha. I got like here. Okay. Then This is K by concentration of H plus. Are you able to understand that the substitution? A minus, in place of A minus, I am substituting K1 into, what is that? K1 into concentration of AHA, that is C1 into C1 minus C1 alpha 1. I am neglecting this. Not common one effect. Remember, not common one effect because it's a weak electrolyte. Plus, come on, what is that next? B minus. What is B minus? K2, very good, into concentration of HB. What is concentration of HB? Concentration of HB, sir, here C2 into 1 minus alpha 2. No, 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 not like that. C2 minus C2 alpha 2. Alpha 2 C2, weak substances. Let us ignore that one. And if it is so, then what happens? This is C2 by concentration of H plus. What is your aim? I want to have concentration of H plus ion. This and this I'll take LCM and take here. It becomes a square. And Ka1C1 doctors. Now your time came. What is H plus ion concentration? How it is coming? I don't care, sir. I want to enjoy the formula Ka1C1 plus K2C2. Job is finished. If you are saying what is pH of mixture of two weak acids, very simple. First of all, find out H plus ion concentration, the root, K1 value given to you, concentration given to you, K2 value given to you, C2 given to you, substitute and enjoy the beauty, and then find out pH value, right? Go ahead. Now, there is a small question and discussion with scientists. Doctors, if you are involving, I'm very happy. Otherwise, it is not a tensionable job. Don't take tension. Be under normal, cool condition. Suppose, for example, if a sincere student is thinking, sir, you are saying about pH of mixture of acids, but you are saying the word weak acids. When you say the word weak acids, why don't you count water also? Because water is also a weak electrolyte and it has a tendency to give H plus ions, of course. Then why don't we count that one also? Yes, this is a very beautiful thought process where someone should say that in case of common ion effect, you said H plus ion should not be counted as you said in case of pH of 10 power minus 5 molar, 10 power minus 6 molar. But when I jump to 10 power minus 8 molar, 10 power minus 7 molar HCl, then I have added water also. I have counted H plus ion concentration. Then you realized, yes, common ion effect is meaningful for a particular range of concentration of acids. But once you go beyond that, right? If suppose you are going beyond the concentration of that H plus 10 power minus 7, you have to say, sir, water molecule is suitable. Hence, we have discussed in previous classes that common ion effect is applicable up to certain range. Here also the same story takes place. We don't have common ion effect here. We are having simultaneous solubility. So a student should have a thinking process. Why don't you talk about three substances undergoing simultaneous equilibrium? Yes, if it is so, a new case is developed here in this case, and let me enjoy with our scientists that this case should be created a case like that. Mixture of HA, comma, HB, and ionization of water also to be counted. All are weak acids. If it is so, then how to proceed? Very simple, sir. Very simple. What you are doing? You are doing a simple game that H plus ion, the total cationic charge must be equal to total anionic charge. Now, I'll just have a conclusion from the previous, because if people are genius, you can catch it easily. H plus ion concentration total must be equal to concentration of A minus from first acid, concentration of B minus from second acid, and I think Call service. मोहम्मद उबैदुर रहमान, आप आंसर दिए थे 55.55, बेटा ये 55.55 जो है, दिस इज कॉल्ड मोलैरिटी ऑफ वाटर, राइट? H plus ion concentration अलग चीज है, मोलैरिटी ऑफ वाटर अलग चीज है. Seekers are in the Seekers are classes. SK sir, I think that class. ఉన్నారా ముందు వెళ్ళిపోయారు క్లాస్. ఇప్పుడు దాకా వచ్చారు సార్. దీనికి అడగండి, క్లాస్ లంచ్ ముందు సార్ కొంచెం నాకు చెప్తున్నారు చెప్పండి. ఇప్పుడు మనము వాట్ చేస్తున్నాము, 23rd ఐఐటి ఎగ్జామ్ ఉన్నది, కొంచెం సార్ నాకు పట్టుకుంటున్నారు అన్నెసెసరీ number of times this calling, check up whether everyone is available or not. If they are coming for doubts, you can clarify at any time. I said the students, you are free to ask any time doubt from 7 a.m. to 10:30 p.m. Class, college, campus, కొంచెం డిప్లొమాటికల్ డిస్కషన్ చేయాలి. ఇది మనం వార్ టైం, ఇది చాలా ఇంపార్టెంట్. క్లాస్ అదే నో ప్రాబ్లం. క్లాస్ మీరు 4:30 చూడండి ఇక్కడ మై టైమ్ ఇస్ ఫ్రమ్ 4 o'clock, 4:10 to 6. అందరూ ఉండాలి. ఆల్ ది బ్యాచెస్ షుడ్ బి దేర్ ఇన్ మై క్లాస్. ఎస్కే సార్ ఇక్కడ ఉంది 4:10 to సీనియర్స్ చెప్తాను. షిఫ్ట్ చేశారండి, షిఫ్ట్ చేయలేదా? ఇలా షిఫ్ట్ చేసుకోవాలా? నేను స్టడీ అవర్ అని చెప్తాను. 6 to 7:50 తీసుకున్నాను. Is it over? Shall I? Yes. Is it over? Done. Thank you very much. Salaam.